Hi all, this is Mr. Yeager for Physical Science. We're looking at physical chemical properties and physical chemical changes today. This is kind of a following up to the lecture on matter, the types of matter we have, pure substances and mixtures. And now we're looking at being able to describe that matter and how it can basically react or change, all right, and whether that's physical or chemical, okay? So we're going to be looking at physical chemical properties and physical chemical changes. On the test, you're mainly trying to determine which one is which. Like if I give you a property like flammable, is that a physical property or chemical property? And then if I give you some scenarios, it's a physical or chemical change. So there's some key things, key word association we can use to try to understand which one is which. You don't really have to worry about intensive versus extensive anymore on physical science. In chemistry, we used to. Intensive physical properties is something like color, where it doesn't change no matter how much you have, versus extensive is something that will change, like mass. Mass would be a physical property, but an object could have different masses depending on how much you have of it. So we're not going to worry about that so much. So the beginning here is basically where in class we go, okay, what physical and chemical properties can you see in this picture? You might not be able to see both. So this, again, dates me some, showing a picture of Napoleon Dynamite. All right, we could sit there and describe his jacket. It's a blue jacket. It might have some texture to it. His hair is red. It's curly. Those would be physical properties. Not much chemical properties showing there. This one, it's wood rotting. Okay, with wood rotting, that right there is a chemical property. The fact that wood can rot, that's a chemical property of wood. Now, it would be what makes it rot would be what's involved with the chemical property. But again, now we have actually two different substances in this. The rot and still some clean wood, both of those have individual physical properties because they're made up of different types of matter, different compounds essentially, all right? So the wood is rough, it's brown, but the mold on the rotting on the part is probably softer, probably a little wet, and it's green. It's kind of yucky, okay? Maybe it has a smell. Right here shows me with the Grand Canyon a long time ago when I went. All right, but right there, again, we could go through the physical chemical properties that might be in the rocks in the Grand Canyon. Okay, we also have water. Water is liquid in this case, wet, maybe cold, maybe hot, slippery. All right, chemical properties would be how does water react with different substances around us. Okay, so with physical properties is basically what we call qualitative observations, things that we sense. So anything that I can sense about that object is a physical property of it. What does it look like? What does it feel like? All right. What's it taste like? What does it smell like? Those would be your senses. Okay. You technically could say, what does it sound like? I don't know why I have touch and feel there. But what does it sound like? I mean, that would be maybe a physical property of it. Another form of physical properties is basically anything you can measure about it. Okay. Basically, things that we can measure in a lab about it. Mass, density, volume, temperature, those are physical properties as well. So things that we can sense and things that we can measure are physical properties. Chemical properties, on the other hand, are describing how it will react. Okay? Describing how it will react. All right? And how that then becomes something new. All right? So again, anything involving fire and how that object reacts with fire, that's a chemical property of that substance. All right? So if you see the words flammable, combustible, those are chemical properties because you're saying this is how it's reacting with oxygen. Rusting, corroding, okay, rotting, all of those things are chemical properties that occur. All right? So again, how can I make sure I don't mess this up? Okay, how can I make sure that I give you a property as a physical or chemical? There's a couple things you can ask yourself. Okay, ask yourself basically the definition of physical. Is it something that I'm sensing or that I can measure? If you say yes to that, it's physical. Or ask yourself, is this object reacting, burning, changing? That's going to tell me that's a chemical property. So you got two very separate questions where you can sit there and be like, okay, is this something that I can, again, say that it's going to change to something new? That must be a chemical property with it. So if we do a couple quick examples, blue color. Color is something that I see, so that's a physical property. Brittleness. That's again something that's just like the texture of it, how it interacts. Like again, doesn't change what it is, but that would also be a physical property. Odor. That's something I'm smelling, also a physical property. These are all unique about the object. Here, reacts. Once you see that word, you don't even have to read the rest, but reacts with acid to form hydrogen, that's a chemical property. It's telling me how it reacts or changes to something new. This is always a tough one, melting point. People get confused with this one because they're like, it's changing into something. But if I have ice, okay, this is basically saying ice turning into water. Liquid water. Well, what's ice? Ice is water. It's just changing into liquid water. Am I changing it into something different? No. So melting point is actually a physical property, something I can measure when it changes states from solid to liquid. That one is a tough one. State changes are physical changes we're going to learn. So they're physical properties. Combustibility, this is related to fire. So this is a chemical property. Okay? So physical, again, what I'm sensing versus or watching or measuring, while reacting and fire is chemical. If I look at physical changes, so I kind of already said this. Physical changes is where I'm changing what the object looks like, but not what it is. Okay? That's what I'm saying by what it is chemically. It's still the same substance. Still same substance after you do something to it. Okay? I mean, silly ones would be, I fold a piece of paper. That's a physical change of the piece of paper. It's still a piece of paper in my hands, but I'm just changing the shape, the size of it, and so forth. And so that would make it a physical change. So again, cutting, I mean, these are again examples. Cutting hair, cutting grass, you're still leaving the grass on the ground. It's not like you run over the lawnmower and it turns blue. Okay? It's still green grass. I hope it doesn't change blue. All right? Changing the temperature. It's still the same substance. You're changing temperature, you know, when your body might have a fever. You're still who you are. You're just having a fever. It's a physical change. The one that's the most confusing, though, as I already said, is state changes, where you're changing something from solid to liquid to gas. That is a physical change. When you melt water or ice, it's still water. When you boil water, it's steam, it's still water. Okay, and vice versa. So be careful with state changes. Chemical changes is where you create something really, really, really brand new. Okay? It is not what it once was. It doesn't smell the same anymore. It doesn't taste the same anymore. I know we could sit here and be like, here's an egg, and here's an egg. Here's some eggs. They're still eggs. Sure, but does this taste anything like that? Does this feel like anything like that? Do they smell the same? We still call it eggs, but it's cooked now. And so that's one of the main examples. An example of a chemical change is when you cook something. Cooking is chemical reactions occurring. Now, if you're just heating it up, that's not a change. But if you're actually cooking it, that's a change. And so what we have to do with chemical change is look for the signs. Does the color change? Does the odor change? Was there fire, involved? Did the object catch on fire? Once that happens, it's a chemical change. All right? We have something called a precipitate. This is where you have a solid form when you mix two liquids, but there's no freezing or boiling or anything like that. It's just, there you all of a sudden have this solid form. You have gas forming when you shouldn't. Okay, again, it's not because of a temperature change. It's you've mixed something and a gas forms. Okay, that would be like baking soda and vinegar. When there is a clear energy change occurring, that could be a sign of a chemical change. Again, we got to be careful with temperature a little bit, but if we do actually have something increase and you haven't done anything, there might be a chemical change occurring. Okay, if you're not literally heating it on your own. Again, these last ones, these last ones is where like you have two liquids at room temperature and you mix them and all of a sudden something happens. It's not like you're heating them up or cooling them off. It goes on their own. So that's what a chemical change involves. So how can I say whether I have a chemical or physical change? Basically, you just ask yourself this question in the middle. Am I changing this to a brand new product? Is it something that wasn't the way it was before, and I have no reason to think that it's just changing state, or that it is, the temperature, I'm forcing it to change, type of thing. Is it something that's changing just because these two things react? That would mean you have a chemical change. If you don't say that, it's a physical change. Okay? So examples here, wood burning. That would be a chemical change. That wood cannot burn forever because it turns into something that doesn't burn. Slice of bread cut into 2 pieces, that's a physical change. Butter melting, that would be a physical change. It's just becoming liquid butter. Food is digested in the stomach. That's a chemical change. That food does not come out the same way that you put it in, because you get what you want out of it and then it comes back out. Okay? It changes into something new. I know that's gross, but that's an example of a chemical change as well. All right? So that's it. So again, being able to distinguish between physical chemical properties and physical chemical change, that's basically what we just reviewed today. All right? Thank you.